Representing the Global Carbon Project, we have Glen, who's the research director at the Center for International Climate and Environment Research from Oslo, that's CICERO. Glen is on the scientific steering committee for the Global Carbon Project and will present this latest analysis, which was released yesterday. We also have Matthew Jones, who's the senior research associate at the Tyndall Center for Climate Change Research at the University of East Anglia. And he contributes to the Global Carbon Project in quantifying carbon emissions from land use change and the uptake of carbon by land and by oceans. The second organizing partner of this event is the Constraint Project. It's an EU Horizon 2020 funded project, and like any self-respected Horizon 2020 project has a very long name, so it's constraining uncertainty of multi-decadal climate projections. It's a collaboration between 14 European universities and institutes, and they band together to develop a better understanding of both natural and human factors, how they will affect climate in the coming decades. And it has just released its first report. It's called Zero In, on the remaining carbon budget and decadal warming rates, and the remaining carbon budget will be the focus of today. And representing the Constraint Project, we have Joeri Rogelj, who is the lecturer of climate change and environment at the Grantham Institute for Climate Change at Imperial College London. He's a long-serving author of the UNEP emission gap reports and has contributed to IPCC reports AR5, the special report on 1.5, and now is a lead author on carbon budgets for the sixth assessment. So we'll start off with Glen just introducing the research of the latest analysis of the Global Carbon Project.
Want to introduce Paula first?
We'll have another panelist joining us shortly, and we'll introduce her. Oh, there she is. Okay, great. So we also have with us Paula Janguaspara, who's the Decarbonization Strategies team lead at Climate Analytics. She works on decarbonizing of the energy sector in the context of the Paris Agreement, and especially on phasing out coal and other fossil fuels. And she also contributes to the Climate Action Tracker. So, okay, now over to you.
Okay, thank you. It's nice to be here. So, as Ella's just explained, myself and Matt will first describe the global carbon budget, and then we'll hand over to Joeri to explain remaining CO2 emissions, and then we'll open for discussion. So, many of you may have already seen the numbers that have come out from the global carbon budget was released overnight. This year's edition, we update it every year with the latest emission statistics and make an estimate of emissions in the current year. So in the next 10 minutes or so, I'll talk through a part of the budget and one half, and Matt will talk through the second half. So the whole effort, the global carbon budget, is quite a team effort. It's not just us that do all the work. There's 76 people directly involved in this year's budget, but a much broader range of people making measurements out in the oceans, collecting CO2 data in different places, getting estimates of land use changes, energy statistics, and so on and so forth. That paper that's mentioned there in the middle, shown there in the middle, has all the data and description of the data. The two other papers shown on the left-hand side, two commentaries which bring out some of the results. And on the right-hand side, a few resources that we have. The first one, top right, is the web page where you can find PowerPoint presentations. Much of the material I'm going to present now is available there, all the data, figures, you name it, it's there. And on the bottom right is the Carbon Atlas, which allows you to interact with the data, plot the data, compare countries, and so on. So what is the carbon budget? It's really an accounting, a balance of the sources and sinks of carbon. So we have carbon dioxide going into the atmosphere and coming back out of the atmosphere. And the carbon budget is really a process where we go through and analyse that in detail. So it's got these 5 main components here. On the source side, the CO2 that we're putting into the atmosphere, that's the CO2 emissions that we get from burning fossil fuels or using fossil fuels, also cement production and so on. We have emissions going into the atmosphere from land use change, deforestation. But of the CO2 that goes into the atmosphere, a part of it is taken back out again. About 25% is taken up by the ocean, about 25% is taken up in the biosphere, and the remaining half roughly stays in the atmosphere. And it's that part that stays in the atmosphere which is causing the temperature increase and climate change that we see today. So I'm going to talk mainly about fossil carbon emissions, so the grey part in that figure, and Matt is going to talk about the other 4 components, so he has the more challenging job. And we're going to talk about the historical part, so looking at what has happened in the past, and then we're going to hand over to Joeri, and he's going to discuss CO₂ emissions into the future. So getting into the fossil emissions. So these are the results that we released overnight. The main sort of headline result is that little red dot on the right-hand side there. Global emissions went up about 0.6%, estimated based on monthly data that we have available up until about September, October. There is some uncertainty about that estimate. Emissions could have gone down a little bit, or they could have gone up higher. The 0.6% in context is a little bit lower than the growth rate of over the last 10 years, although, given that you have little ups and downs from year to year, I wouldn't think that the 0.6% is not in line with current emission trends. The 0.6% is much lower than the growth rates during the 2000s, when emissions were going around about 3% per year. As you see, emissions have grown pretty steadily over the last decades, about 60% higher than in 1990 when the first IPCC assessment report came out, and about 4% higher than 2015 when the Paris Agreement was adopted. So breaking this down into components, first of all, I'll look at what's going on at the country level. So in the carbon budget, we split down emissions by countries and make a projection for the top 4 emitters and the rest of the world. So those countries, China, US, EU, region and India, make up about 60% of global emissions. I'll just quickly say a few sentences on each one of those. This year it looks like China's emissions will go up about 2.6%, which is not so different to emissions growth in the last 2 years. China had a huge increase in emissions during the 2000s. That's slowed down dramatically since 2010, and emissions are just starting to rise again in the last few years. China is really a tug-of-war between declining GDP growth, the economy, sorry, not declining GDP, lower GDP growth, a weakening economy, and the Chinese government trying to re-inject spending into the economy, infrastructure investments to try and boost GDP. And the infrastructure investments usually involve a lot of cement, a lot of steel, a lot of coal, and so on and so forth, and often push up emissions. India, down the bottom, I'll skip to that next. There's an interesting story this year. In the last decade, Indian emissions have been growing at around about 5% per year. This year, we're estimating about 1.8%, which is a big change, unexpected change. We weren't really expecting this to happen. There are a few specific circumstances in India which are causing that to happen. It's a weakening economy this year. The GDP growth is not as strong, but in particular, there was a very big monsoon this year, which cuts into coal power generation, and there was also a very big year, record year probably, for hydropower generation. So essentially, the coal power generation has been displaced by hydropower. So moving forward next year and so on, I'd expect Indian emissions to return to that sort of decadal growth rate of around 5% per year. The US and the EU I'll tackle together because they have the same numbers. Coincidentally, both of them we expect to go down about 1.7%, and both because coal production or coal consumption has gone down about 10%. Similar factors in each country, a shift away from coal power. In Europe, driven by the higher price in the European emissions trading system. In the US, driven by the cheaper natural gas and solar and wind. The rest of the world, the black line there, has grown about 0.5% in 2019, which is a bit lower than the growth rate in the previous years, primarily due to a weaker economy. We have a lot of data in the global carbon budget going down into all sorts of countries. This figure here just shows the top 6 absolute emitters. I'm not going to go into the detail. I'm just using this as a transition to go to these same 6 countries, but in per capita. So when we're looking at the CO2 emissions going into the atmosphere and what's causing climate change, we have to look at the absolute emissions, what are the total emissions going into the atmosphere. Whereas when you want to start to look at mitigation, how to share out the mitigation burden, which countries have to mitigate more than others, and so on and so forth, it's very useful to look at per capita emissions as one indicator. You'll see that the US has quite high per capita emissions. They've been declining over the last decade, but still 3-4 times higher than the global average. At the other end of the extreme, Indian CO2 emissions per capita are about less than half the global average. China and the EU, surprise to many, have around about the same per capita emissions. You can see China just edging above the EU there, but within uncertainties, I wouldn't make too much noise about that at the moment. But both China and the EU are above the global average in terms of per capita emissions. This figure, a little bit similar to the last ones, except I'm showing energy, not CO2 here. And the reason I'm showing energy is so I can show the size of renewable energy in the figure. And I'll look at this one in terms of emissions in a minute. Coal, oil and gas are completely dominating the global energy system at the moment. Around about 80% of energy consumption is related to coal, oil and gas. Oil and gas are both growing very strongly. Coal is having a few ups and downs, and coal may have peaked in 2012. I wouldn't go over-interpret that. Maybe coal will come back up again. Bioenergy is quite an important energy source. Not in all data sets. This here includes traditional bioenergy, and that's sort of growing modestly. Hydropower is also growing. Down the bottom there, we have huge growth rates, relative growth rates of wind and solar, but from a very low level at this stage. So they have quite some distance to go before they really start eating into the coal, oil and gas. Converting that into emissions, this year for the first time we've done a projection of coal, oil and gas into 2019. We're expecting coal emissions to go down slightly, primarily because of electricity production in different countries, which is offset a little bit by coal use in industry. Oil is growing robustly. It's used a lot almost dominantly in transport, and robust growth in developing countries, but it's not going away in developed countries either. Lots of challenges in mitigating, getting away from oil and transportation. But one real big surprise, I think, is the emergence of gas. Since coal has maybe peaked in 2012, gas is dominating emissions growth. About half emissions growth in the last decade is coming from natural gas. So we can't forget about natural gas. There are benefits in shifting from coal to gas and electricity production. Emissions will go down a little bit, but emissions will not go down to zero. And so emissions will just rise a little bit slower if we use gas instead of coal. So gas is only a very short-term bridge. This year in the report, I won't spend much time on this figure, but we go into looking at the sector detail. This is using data from International Energy Agency. The data is not as recent, only goes up to 2017, but you can see the dominance. Now, almost half global emissions coming from electricity, heat production, energy production, more broadly. Industry, second most important, around about 23%. Both electricity and industry are starting to slow down a bit, which is maybe a positive sign, but we still see very strong growth in emissions from transport, both domestically, which is the red line there, and also international transport, called bunkers, international aviation, maritime transport, growing quite strongly. And now I'm going to transition over to Matt. So I've talked about the top half of this figure, the fossil fuel emissions. Matt's going to dig into land use change and the rest of the carbon cycle, ocean sink, land sink, and what remains in the atmosphere.
Thanks, Glen. Yeah, so thanks, Glen, for talking about the fossil emissions. I'm going to move straight on to the land use change emissions, which is the second source of carbon dioxide to the atmosphere. So the first thing to note is that while fossil emissions have risen rather steeply over the past half a century, emissions from land use changes have remained relatively stable. So in the middle of the 20th century, land use change emissions were roughly comparable in magnitude to fossil CO2 emissions. But by virtue of the increased fossil emissions, we now see that only 14% of total emissions of CO2 to the atmosphere come from land use change. Land use change emissions are the most uncertain component of the budget. and this makes it very difficult to actually detect any trend that did occur. The land use change emissions estimates are based on national FAO inventories, a range of other land use products that are derived from satellite remote sensing, and some supplementary land use history records. The global carbon budget incorporates two models with different blends of these input data sets, and the resulting model estimates diverge quite significantly over the past decade, which is why we're so unsure of the direction of travel. Oh, excuse me. So for 2019, we do make a projection, and that's based on fire hotspots alone. So we're very uncertain of this. So this is detections of active fires that are happening in near real time. And they do indicate that there's been a greater number of fires in 2019 in key deforestation zones like Amazonia and Indonesia, but nothing like what we saw in the 1990s or early 2000s. So while there are some signs of a recent uptick in land use change emissions, we have low confidence in these. So I'll now move on to talking about how we close the global carbon budget. So that involves making estimates of the sinks of carbon dioxide out of the atmosphere. So the ocean sink has risen quite continuously over the past half a century, and we now benefit also from estimates of the ocean CO₂ sink that are based on repeated observations of CO₂ concentrations at the ocean surface, and that's what you see in the blue line here, compared to models, which is the black line. The land sink has also continued to increase, but with significantly more interannual variability, and that results from regionality and seasonality of weather patterns year on year. So a good example of that is the way that the El Nino Southern Oscillation affects temperature and rainfall patterns in the tropics. So as CO₂ emissions have risen, the atmospheric stock of CO₂ has grown at an increasing rate. We have high confidence in the rate of increase because we have a real wealth of direct and very precise observations from a global network. The growth in the stock of atmospheric CO₂ indicates that about 45% of emitted carbon dioxide remains in the atmosphere. So now with all this information that we've compiled as part of the global carbon budget, we can start to try to understand the fate of anthropogenic CO₂ emissions. In 2009, in the period 2009 to 2018, 44% of total emissions remained in the atmosphere. 29% were apportioned to the land and 23% apportioned to the global oceans. But then we also have a kind of a budget imbalance, which represents the carbon that we're not able to account for in the budget. Because we know our atmospheric growth rate so well, we're able to say that this is either because we overestimate the sources or we underestimate the sinks of carbon dioxide. But the budget imbalance is a relatively small term of the budget. So it's now time to pass over to Joeri, who will talk about, oh, apologies, no, it's not. Oh, there we go. Thank you.
Just waiting for the presentation to come up, yeah. Thank you very much. Whereas my two colleagues, Glen and Matt, presented the latest annual update of the Global Carbon Project, as Ella introduced in the beginning, I will be presenting our results of the Constraint Project. The Constraint Project is a European or EU-funded Horizon 2020 project with 14 partners, research partners across Europe. The goal is really to develop a better understanding of how natural and human factors will affect the climate in the coming decades, and really using this to improve our climate projections for the next 20 to 50 years. A key aspect of the project is indeed to link Earth system scientists and their institutions and their findings to policy relevant fora like the UNFCCC. So in order to make this translation happen, there we go. The project that actually only started mid of this year will be presenting annual zero-in reports. And every year we will be focusing on one or two topics that come out of the research of the last year, the Earth system research, and that are of particular interest to the climate change negotiations. This year it is the remaining carbon budget and decadal warming rates. I will be speaking about the remaining carbon budget. The decadal warming rates we have presented a couple of days ago at another side event. This report is available on our website. If you are interested in these other topics, please go have a look. We intend to update these reports annually, just like the Global Carbon Project, so we can give you an annual update of how our progression of knowledge in science, what the implications are for the remaining carbon budget. There we are. I don't really know. Thank you. One back, please. There we go. Yeah, so I want to start my presentation with a slide that you have seen from my colleagues, which is the global carbon budget, because I want to explain to you the difference between the global carbon budget and the remaining carbon budget. And what you can see here is indeed the balance between sources and sinks, and what we are interested in here are the gray and the yellow parts, basically the human emissions into the Earth system. And there are a few insights that we can already get from this, from the global carbon budget that was presented just before. Can I get next, please? The first implication is that we have already emitted around 2,300 billion tons of carbon dioxide into the atmosphere since 1875 to 2019. And this has caused about 1 degree of global warming since pre-industrial. Now, we also know that global warming is roughly proportional to the total amount of carbon dioxide emissions. And that brings us then to the remaining carbon budget. And from looking into the past and understanding what has happened, we now look into the future and we try to understand what we have to do to achieve the goals that we have set under the Paris Agreement. The question is really, if we want to limit warming well below 2 degrees or 1.5, how much CO2 can we still emit? And that number we call the remaining carbon budget. Next, please. No, one back, please. There we go. So, over the past couple of years, the remaining carbon budget, or there have been lots of studies published that provided numbers for the remaining carbon budgets, and they differed a lot. Some indicated a much larger carbon budget than was indicated before. Other studies suggested there was no carbon budget left at all. So one of our intentions with this project and particularly with this task is to create a bit of clarity of how is it possible that these carbon budget estimates differ so much. And one of the things one has to understand about the remaining carbon budget is that unlike the historical carbon budget, which measures what has happened in the past, we can't measure the future, and there are a couple of value judgments and choices that have to be made before we can actually scientifically estimate what the remaining carbon budget is. Next, please. Examples of these choices might sound really simple, but if they are not clearly communicated, they really confuse what numbers actually means. One of these choices is the global warming limit we're interested in, 1.5, 1.7, that speaks for itself. But then also one needs to make a choice about the probability with which one wants to achieve or limit warming to below this temperature limit. Is it just the best estimate that we want? Do we want to hedge against uncertainty, have a 66% probability, a 90% probability, and so on? And further, and finally, we do not only put carbon dioxide in the atmosphere, but we also need to make decisions and choices about what we assume non-CO2, methane, nitrous oxide, will be contributing into the future. And once we have made these value judgments and these choices, next please, then climate science, what we know of climate science, can tell us how much the remaining carbon budget is. And what we then know from climate science is how much warming is remaining until we reach the limit of interest, how much warming we expect per ton of emitted CO2, what the climate effect in terms of forcing and warming is of the non-CO2 emissions that we expect to happen in the future, and also what the feedbacks would be that come on top of this all. And that altogether provides us then with the estimate of the remaining carbon budget. Now that is still a global estimate. If we want to translate that to the national level and use that for national policymakers, yet again a set of choices have to be made. If you can go 2 slides forward, please. The first one is considerations of fairness and equity. The global carbon budget, or the remaining global carbon budget, is a given based on science. But if you want to go to the national context, you need to take into account considerations of historical responsibility, the development status of a certain country, or the capacity of those countries to reduce emissions. And if you can go one further, then we have the full picture. One also needs to ask which emissions are actually included in national inventories, are aviation emissions included, and also if international offsetting and emissions trading is included. So this really sketches the entire set of decisions that need to be made for the remaining carbon budget. If we can go to the following. Ultimately, we will look here at the global remaining carbon budget and not go to the national level. We identified 5 components that are necessary to estimate the remaining carbon budget. The first is the historical warming to date. How much has Earth warmed until now? And we have a recent study here that highlights also the temperature metric, or the way in which global mean temperature is calculated. And we suggest there that this temperature metric needs to map closely to the impacts that we are trying to avoid under the Paris Agreement, rather than simply representing an arbitrary number. If we can go forward. We need to make estimates about future non-CO2 warming. They come from a variety of sources. This component we estimate by taking long-term pathways, integrated pathways of how society can develop, and we estimate the contribution of non-CO2 at the time that global CO2 emissions reach net zero. So the sources, some of those sources will continue in the future, for example, like waste or fertilizer use. And so we estimate that around 0.1 to 0.2 degree of additional warming will happen from those sources. Next, please. Then there is how much warming we expect for each ton of CO2. Here there is no real evidence to suggest that we would need to assume anything else or anything beyond what was assessed in the IPCC Fifth Assessment Report. Next, please. Finally, recently, it has also been, there have been quite a few studies looking at whether warming actually will stop if we bring emissions down to zero. This is called the Zero Emissions Commitment. Currently, this is really an open research question. It could be slightly positive, it could be slightly negative. This is an additional risk in mitigation strategies. Here we assume it to be zero with a range of 0.2. And finally, there are unrepresented Earth system feedbacks like permafrost thawing that are generally not included in climate models yet, or not in the ones that have underlined the assessment above. And so we need to take them into account in addition. If you can go to the next one. Then this illustration should then show how these 5 components basically fit together. We have the historical warming at the bottom and the warming limit of interest at the top. What we expect that non-CO2 will contribute is subtracted from that. If warming warms more once we get to net zero, we also subtract that. And then it goes a bit faster than I can talk. Anyways, with this combination of 5 factors, we can then estimate the remaining carbon budget that we read down at the bottom. And you have now waited long enough. So if you go to the next one, currently from 2020 onwards, the remaining carbon budget, again, highlighting the two choices we need to make here for a 1.5 degree level with, for example, a 50% chance of limiting warming to that level would be 395 billion tons of CO2. If you want a higher probability, this is smaller. We only provide here a limited set of probabilities and of warming levels. So going to show that the combination of value judgments and physical science is critical in determining the exact number you talk about when determining the remaining carbon budget. If we go now to the last one. So if you go to the website, you can see, you can find all the details of all the assumptions that we make in this. And as I said in the beginning, we will be updating the assessment every year with the latest findings that are of relevance to this value. Thank you.
Thank you very much, Glen, Matt, and Joeri. And now I would like Paula to react to this, and maybe it would be great if you could tell us how useful you find this carbon budget metric in the kind of work that you do, which is deriving policy recommendations for governments to get their emissions in line with the Paris Agreement. And also, as we saw that emissions grew last year, and we saw just a small decline in coal, and since this your work focused a lot on coal, could you maybe talk about some of the policy drivers behind this decline? And also, there was an alarming increase in gas. So yeah, what's the story with gas?
Thank you, Ella. So I guess there were two parts for your question. First of all, how useful do I find the carbon budget metric for the work we do? I mean, evidently, it's a very alarming figure once you see how much budget we have left. And it's extremely important because that's the space we have in the atmosphere. However, as you were saying, this metric is global. And usually we're not working at the global level, we're working with national governments or even at the regional level. So a very, very, very important part of the work is trying to translate this abstract concept of the carbon budget to a metric that can inform policy making. And for that, you also have to make a set of assumptions. Joeri, you're right. How do you divide this carbon budget? What part corresponds to each fuel? What part corresponds to each country? And they're difficult decisions or assumptions that you have to make in that. But luckily, the IPCC special report, and thanks to your work, Joeri, as well, has provided with a large number of techno-economic pathways that show many, many ways that we can remain within that carbon budget, but not showing you the overall figure of a budget, but a trajectory to that. And I think trajectories are extremely important because this long-term carbon budget does not necessarily give policymakers a very concrete target for what's my NDC, how it should be, how aligned is it with the target of 1.5 or limiting emissions to a budget that is reasonable with our national circumstances. So it is very useful, but I think it needs a lot of additional work to be translated into policy recommendations, and that's a lot of the work we do. And yeah, maybe as part of that, a lot of what we've done focuses on the electricity sector, because you saw how important it is, or how much it contributes to emissions. And within that, a big majority of the emissions is coming from coal. So we're looking at what is the carbon budget and what is the trajectory that coal emissions will need to follow to be in line with the Paris Agreement compatible. Is quite shocking when you see the reduction. So recently we published a report globally. We saw that emissions will need to fall around 80% below 2010 levels by 2030, and the reason and then move from that to almost a full phase out by 2040. The reason I'm mentioning this is because when you translate that to what actually countries are planning in terms of expansion of their energy system and how they're planning to meet the needs for increasing energy demand, it's quite shocking to see how much coal is in there still in 2019. And how much of that budget, if you were to account for those committed emissions of the infrastructure that's being built now, how much of those committed emissions will basically blow your entire carbon budget, not only for the power sector, but in general for your country? So unfortunately, I have to say yes. There is progress with coal, and we've seen it, and we've seen effectively policies and benchmarks being adopted by investors, being adopted by governments, the Power and Past Coal Alliance, and many others that have benchmarks, but there is a large number of countries that's still not taking this into consideration in their energy planning, so there's quite a big risk there. Yeah, I'll stop there and we can follow.
Okay, so maybe we'll just have a quick round of reactions from the panel, and then we'll open the floor for questions. So maybe we'll start with Joeri, and then we'll go with Matt, and then Glen.
Yeah, thank you. I think these are really valuable insights. It speaks for itself that this global number is a very rough metric, doesn't tell very much, and it is exactly for that reason that I think we come to these fora to present this to people. But I think many of the people here in the room are actually people that also translate this knowledge again then into policies and into national action. And I think, yeah, I fully agree that that's an essential step in making this scientific information further actionable.
Yeah, I mean, these guys know a lot more than I do about fossil fuel emissions. But I mean, from the outside looking in, I see a huge amount of opportunity in the future as we move towards an energy mix which is more dominated by renewable energy. I see new jobs being created. I see opportunities for people who already have the skills required. I see massive opportunity to make this a positive thing, and I'd like to kind of inject that into the observations, I suppose.
Yeah, I'll just essentially come a little bit the same direction from Paola here. You know, when we're talking about the global numbers, it's all very abstract. Off in the distance, it's a global number, not my number. But when you start to go down to countries or to regions or to fossil fuels, coal, oil, gas, or to sectors, electricity, transport, then it really comes home, the challenges. And everyone, you know, thinks it's a big global problem. I'm not so important in that global picture, so, you know, my transport emissions aren't that important in comparison to the big global picture and so on. But when we fall into that trap, it just means emissions keep going up as they are. So we've got some tough choices in a sense.
So now we're going to open the floor for some questions. We have a couple of roaming mics. So if you could just raise your hands, and maybe we'll take a couple of questions. So I see one here in the front. One there. And third one, yes, Leo.
So I'm Torsten Tanner. I'm a marine carbon chemist from Geomar in Kiel, Germany. Thank you very much for the work you're doing. That is an incredible resource for the community and for the policymakers, I'm sure. I have a specific question about the ocean sink, and you showed, Matt, a mismatch between the observational estimate and the estimate from models. And maybe you want to comment on what is the cause of that mismatch, which numbers are you using for your budget, and does this show a need, observational need, or does it show a need to improve models, or maybe both?
Well, the ultimate kind of goal, I suppose, is to have models that can reproduce observations, because that allows us to project into the future. So I suppose that's why the focus is often on trying to compare what the models are saying with more or with products that are closer to the observations. There is a kind of gap especially in the last decades, but the thing that we do find, which is quite interesting, is that there's a very strong relationship in the variability of the two different lines of product. That's a good sign that the processes are being captured, but perhaps there's some kind of intricate details that are being missed by the process-based models, essentially. Yeah, so I mean, whether or not it shows that our estimates of the ocean sink are unreliable. I wouldn't go that far. But I would say that we need to concentrate on this going forward and ensure that we're making the best use we can of the atmospheric and the oceanic observations. Yeah.
Okay, there was a question there in the back. Leo, yes?
Thank you very much. Leo Hickman from Carbon Brief. It's a question speaking mainly to, I think, Glen's first slide. Is there any evidence that the land sink is beginning to lose some of its capacity to absorb what we as humans are pumping into the atmosphere? It looks, from eyeballing it, it looks like that's beginning to tail off in the last sort of 5 years, or is there too much range of uncertainty within that?
You're staring at the figure too long and you're getting cross-eyed. Actually, there is a slide in the extended slide deck, so a global carbon budget, and you'll find the slides, where we look at what's called the airborne fraction. There is some discussion and debate about the airborne fraction. So what the airborne fraction is the atmospheric increase in CO₂ emissions divided by the total emissions that we put into the atmosphere. So it's a measure of that efficiency. And it's remained at approximately 45% for decades. You know, there's ups and downs with different years, a lot of noise in the interannual variability, but when you sort of run it through an average over that period, it remains remarkably that we still take out 45%. You know, even though we're putting in several times more carbon into the atmosphere every year, we're taking out several times more carbon into the ocean and the land every year. So that's pretty amazing that that's stayed constant. You know, there's a bit of a spread in what models predict going forward. We don't see yet at the global level any indication that that sink is weakening. We do have some regional indications that things are going on. We know, for example, in El Nino years, when we have a big El Nino, it's hot and dry in the tropics, less carbon uptake in the tropics. And so we know there's those sorts of feedbacks at the regional level, but we're not seeing any, let's say, coordinated feedbacks playing out globally yet with the warming that we currently have. But of course, you can't guarantee that we're going to start seeing that in a few years.
Is there anything that you wanted to add, Matt? Or no? We'll go to next questions. We had a couple of questions here in the front. Maybe we'll take two and then you answer.
Thanks. Lawrence Sting, Climate and Earth. In 2000, there was a paper that said that the amount of committed warming in the atmosphere was about 0.6 degrees. Now, obviously, that came from a model that must have been revised down because, you know, at 1 degree now, there would be a negative carbon budget if it wasn't. Do you have any idea what that amount of committed warming, what your estimate would be for that now? Because that must be sort of built into this, obviously.
We'll take another question and then we'll get answered.
Daniel Chacon from Mexico. How mature is the science of a carbon budget to be used as a tool for countries for NDCs determination? And what is needed that countries use it instead of the science is enoughly mature, use it for NDCs calculations? Because we know that it's evident that the past NDCs were not based on carbon budget or temperature references. So what is needed for this conference, the convention, to convince countries to use this tool? Thank you.
Yeah, I think I'll answer both and you can add to the second one. Yeah, so I'll try to answer both and then my colleagues can add to it. On the committed warming, thank you for that question. There is an important confusion in kind of in the general public, but even in the scientific community. It is correct that in the early 2000s there were committed warming runs or models were. They run an experiment, what we call an experiment in the models, in which the composition of the atmosphere was kept constant, and then one looks how much warming would still be added. Now, if you bring carbon dioxide to zero, the composition of the atmosphere does not stay constant. As my colleagues showed, carbon will continue to be taken up by the ocean and the land until a lower equilibrium is achieved. And incidentally, the rate of decline of that carbon dioxide uptake has kind of the same time scale as the rate or the time scale at which the additional warming would come. So our current best understanding for carbon dioxide, if we bring it to zero, is that temperatures stay relatively flat, plus minus 0.2 degrees, roughly. The question about whether this concept is a useful concept to be used for NDC setting and how established it is. The last IPCC assessment clearly established the concept based on multiple lines of evidence. So I think, and also further research and studies have clearly shown that it is a robust concept and have increased our understanding of it. The big if here, of course, is what I also shown in my slide. The global carbon budget is a very easy definable or relatively easy definable quantity. If you start translating it to your national context, you need to make assumptions about fairness, about equity, about relative shares between countries, and unless these are formulated transparently and openly, it quickly becomes a very muddled picture. But one part of the carbon budget that is definitely something that countries can take up, not only in their NDCs, but particularly in their long-term strategies, is that the end point of any climate mitigation strategy, or one important benchmark, should be net zero carbon dioxide emissions. Because that is a requirement, a geophysical requirement to halt warming at any level.
Yeah, I could add a couple of things, but Paola, did you want to add something on the usefulness of the budgets? You mentioned it a little bit in your remarks.
Yeah, okay, sure. So maybe a little bit of advertisement to the work of the Climate Action Tracker. So, I mean, I don't know, yeah, how much future would you have bringing this into the process, but definitely there are countries that have expressed what their interpretation of equity, for instance, is in their NDCs. And what we looked at in the Climate Action Tracker, it compiles a large number of literature studies that looks into what will be the equitable carbon budget for a different set of countries and under different perspectives, because there is no one perspective. And what we found, which is very interesting, I think, is that if everyone or if every country were to, let's say, adopt the definition that they prefer that allows them to go higher in terms of emissions, what will happen if everyone is going to the top is that we get to 3 degrees globally. So that basically means that nationally determined carbon budgets can be informative to a certain extent, but they have to take into account this global perspective. What is the maximum that we should be able to be consistent with the global and collective ambition that is required? And in that sense, we made a study. We know in 2020 countries have to update their NDCs, and there's been a learning process between 2015 where it was sort of a rush thing to come up with an NDC, and now in 2020 where there's a lot more information available for countries on what will be a contribution that will be consistent with the collective effort that we're trying to achieve. And we find that to be roughly in line with a typical 1.5 pathway as described in the IPCC special report, we will need to halve the emissions levels that are implied by current NDCs. So of course, not all countries can halve their NDC emission levels. Some of them are more ambitious or not. But this is a very important benchmark to keep in mind. It's not only your carbon budget and your interpretation of what your budget is, but where we need to go collectively. And I think in that sense, it can be very informative for countries.
Thanks, Paula. Okay, we had one question here in the front, and then another one over there. Maybe we'll take.
There's a couple over.
Yep, great. Should we take 3? Yep. Okay, and then another one just there in the front.
Yes, thank you. I'm Alfred Agdaco from France and former leader for IPCC. And I have a question about your graph about the energies by sources. So you have oil, coal, and gas. That's perfect. Then you have bioenergy, hydro, nuclear, and wind, and other. But why do we have a vegetable production for food? And which is of course different from meat and which emits methane and so on. But what do we have this? Why do we take this into account? Because it's also related to population growth, and it's also energy. It's a different kind of energy, and so it's usually forgotten. I think we should take this into account.
We'll take another question. Yes.
Thank you. Richard Betts from the Met Office Hadley Centre and University of Exeter. I wanted to pick up on Leo Hickman's question actually about the weakening, the potential weakening of the land carbon sink. And as Glenn said, we're not seeing signs of it yet, but we need to be looking out for that. And the models tend to project that it will weaken. The issue here, I think, is that in the global carbon budget, the land sink relies largely on models. So how will we know whether these model predictions are playing out in reality if we're still relying on the models to make the estimate? We've heard, like yesterday, there was some great presentations on use of Earth observation for monitoring forest biomass and so on. There's a lot of work on monitoring tropical forests in particular at a network of plots across the whole tropics now. What is the scope for bringing that into the global carbon budget work? Can we get a more kind of observationally constrained estimate?
And we'll take one more question down there in the front.
Hello, thank you. My name is Ulrich Carnio. I'm from Climate Action Network Europe. I have a question on is it 100 gigatons that is removed from the budget for the Earth feedbacks? And to me, it doesn't sound very much. What do you say about this number? And then secondly, the loss of albedo, is it taken into account somehow in these calculations, and how would that be done? How is that done? Thanks.
Yeah, I can take a few of those, at least get started, and others can chip in. So coming over to your question, yeah, so it's a good question. So first of all, we're showing the carbon budget, so it's important to emphasise, I should have mentioned it also in the presentation, that we're not looking at methane emissions, nitrous oxide, other greenhouse gases, and they're predominantly associated with the agricultural sector, or dominate in the agricultural sector, and so an important share of emissions, off the top of my head, I think 30% or so related to those sectors, so important. Yeah, the energy associated with food that we consume, yeah, I know it's been estimated. I don't know the numbers off the top of my head and how it compares to the size of the energy in the energy system. That'll be interesting to look at, but it's generally not considered, because we're considering the energy system as such, not energy in totality, where you might get different flows, but also the implications on the carbon budget are a little bit different as well. The food that we eat is then sort of respired back out and goes into the natural carbon cycle as well. So I'm not sure if I'm fully answering your question there, but touching around, it'd be good to know those numbers off the top of my head, actually. Yeah, so Richard, thanks for pointing that out. They're good questions, and it starts to get into some technical issues and the evolution of the carbon budget and the way it's done over time. So we used to do the carbon budget in that we knew the atmospheric concentration basically quite accurately, had estimates of the ocean sink and the emission sources, and we took at the land sink as a residual. In recent years, we've been modelling that out, the land sink, individually with Dynamic Global Vegetation Model, DGVMs, trying to model the land sink and the land source. And this has led to the carbon budget imbalance. So this 4% that Matt showed in his figure is essentially a lack of understanding. In terms of observational constraints, there is the use of inversions to get a, are we in the same sort of order of magnitude, territory, ups and downs? Are we getting those sorts of things right? But I would say refer to another EU project carbon-climate interactions in the coming century, which is trying to look much more closely at using different observational data sets to try and constrain different parts of the carbon budget. And we try and leak these into each new edition of the carbon budget every year. So hopefully we'll see things better. But we can talk about some of those details later. Just to mention albedo, do you want to mention albedo, or you can?
Yeah, it's a good question. The feedbacks the additional feedbacks that we take into account are additional to those that are generally already well included in the latest modeling. So albedo feedback is one that is taken into account there. General carbon cycle feedbacks are taken into account there. These additional 100 gigaton CO2, of which you say it is relatively small, it comes with this caveat that this is the estimate of these feedbacks over this century. We know, for example, that the permafrost, once it's thawing, will continue to release methane and carbon dioxide over multiple centuries. So over the next century, we would still expect further CO2 release from that permafrost. However, in the context of the time frame until which we have to get to net zero with these carbon budgets, it doesn't really make a lot of sense to put in all the carbon feedbacks that would happen in the next 5 centuries. So I think it is our judgment that the carbon feedbacks that happen over the time scale that we are now discussing for policy and until the end of the century are the most relevant to be included in this budget.
Okay, a couple of more questions. I saw a hand going up. No, Alex, just here in the front first. Oh, yeah. Yes, sir, first, and then a couple of other ones in the back there.
Thank you. My name is Timo Tyrväinen. I come from Finland. I'm chief economist of Climate Leadership Coalition. My background is in macroeconomics, and certain things started to bother me. So, and it raised to the kind of feeling that if there are some problems with the measurement, that you cannot take them 100% sure that they are exact. In macroeconomics, central banks have posed inflation targets, though everybody knows in macroeconomics that there are problems in measuring inflation. There are growth targets. There are great problems in measuring GDP. Indebtedness targets of the EU. And there are problems with the measurement, but still I'm sure that these targets has been very useful. And therefore, in a way, there may be a bias that macroeconomics, everyone knows that it's behavioral science, that measuring is natural, that it's almost good. But in the natural sciences, you think that you must have exactly the correct number. And therefore, in a way, those feelings that may arise that if you put it transparently, the problems which remain, that you can then say, let's stay out from using these ideas. There in my heart of macroeconomist almost starts to cry.
Maybe we'll take a couple of there, yes.
Hello, my name is Fabio Parigi. I have a question. How do you think should we split the remaining carbon budget amongst the country and sector? And also, eventually, how the price on carbon could influence that, and especially in regard the rights to developing countries to assess sectors and countries.
And one more question just behind that gentleman, yes.
Hello, thank you for the very interesting panel and the very relevant work you provide. My name is Gabriel. I intern for the UNFCCC. My question is, would it make sense to also calculate and provide carbon budgets for certain climate tipping points? For example, I mean, I know there's high still high uncertainties with these tipping points, but for example, we have X amount of gigatons of carbon dioxide left until the Western Antarctic ice shield collapses with a certainty of 33% or something like this. Would this make sense at all?
Over to you guys.
Okay, maybe I can speak about the splitting of the carbon budget to national budgets, because it's a lot of what we do. So I have not been in the process long enough to know this, but what I've heard is that a lot of these equity discussions about how to split this carbon budget were done or started where we had very different circumstances and market circumstances for what mitigation meant. So mitigation and the technologies were a lot more expensive 30 years ago or so on. From where I see it, it will not make any sense, even if a country is poor and developing, to increase their emissions beyond a point. If you have, for instance, by building coal power plants, if you have renewable energy, which is much cleaner and has now a competitive price, which was not the case. So a lot of the equity discussions, I think, are framed not in the most useful way, and I think therefore coming up with one single way or recommend a way to split the carbon budget might not be the most useful metric. I think national circumstances are extremely relevant, and then each country should take into account what are their national circumstances, but also what are the sustainable development benefits that go into a low carbon emissions pathway will bring, and what are the costs, which of course then you get into the equity considerations, where is climate finance supporting that? But I think using equity considerations to split carbon budgets might get you into a trap where we all end up, as I say, going to a much higher emissions pathway than where we are. So I would not recommend one. And I think, yeah, each country should really evaluate all the benefits that going into a low emissions pathway will bring before choosing a carbon budget.
Joeri, do you want to take the question on climate tipping points?
Yeah, it's just quickly on the uncertainty. I'd say with climate at least, the size of the reductions is so much greater than the uncertainty that uncertainty is certainly not an excuse to not reduce your emissions as fast as you can. But on the tipping points, and we've got Richard here who knows quite a bit about tipping points as well, but linking it back to the discussion we had on carbon cycle feedbacks, and we're currently, the Earth keeps taking up 45% or 55%, 45% of the emissions remain in the atmosphere, and that's remained relatively stable, has ups and downs, but we know it's not going to last forever, or we don't expect it will based on modelling. And maybe a little uptick we see now is actually the uptick that's going to continue into the next decades, in which case the budget for that tipping point is gone. Or maybe for another 10, 20, 30 years, we remain at this 45% ratio. And that tipping point, if you like, is some decades away. We just don't know with any certainty. And I'd say that's the same with a lot of the other tipping points. Some tipping points are a bit fast, some are slow, some tipping points are hundreds, some are thousands of years. And to estimate a carbon budget for a tipping point, you could do it, but it would be a very crude indicator, I would think. Yeah.
Yeah, I can maybe add to that in general, we estimate carbon budgets because we're interested in avoiding impacts, tipping points being one of those impacts. In the IPCC, we often have these figures called the burning embers, where you can see the risk of an impact happening as warming progresses. It's kind of colored bars. I don't know if you're familiar with those. And they really also, these bars, they also really show the challenge there, particularly with tipping points. We know they exist. We sometimes know their mechanisms, but it's really hard to pinpoint at what moment exactly these tipping points would happen. So ultimately, it's kind of a risk framing and a risk reduction strategy that one takes by limiting warming to as low as possible or to whatever target one chooses. So one could link it to tipping points, but my understanding of the current state of knowledge of those tipping points and where they are is that it would not be very informative.
Okay, we'll take a couple more questions. We have one here in the front, Bill here.
They're all in different places, the switches here. Yeah, look, I have a question that goes back to one of the synthesis slides earlier, but first a comment on the tipping points versus mitigation pathway issue. And I agree with what Joeri said. If you look at all the uncertainties, then, you know, right now, the most aggressive risk avoidance pathway we have is a 1.5 degree one. We don't know that much more can be achieved, frankly. So that's, I think, the best strategy we would have now is to get onto that pathway. But just looking at the global fossil fuel emission trajectories and then the trajectory of, let's say, the energy carriers on the energy system side, one thing is clear is that that the fossil fuels are beginning to flatten off in general, not totally, but they are. And then underneath that, we have the renewable energy technologies beginning to grow exponentially. So I'm wondering, have you looked at how much faster or how much longer that exponential growth in the primary energy supply from renewables has to go on for before that would actually start to bend over the composite emissions curve for total fossil fuel emissions? I think that's an interesting, like, top level question, because that gets at the dynamics we need to get at in the transformation in the global energy system.
Thanks, Bill. One more question over there.
Yeah, Dan Galpern from the United States. I think for Joeri as well, at the end you showed a slide with 2 columns and how much carbon budget is available remaining if we wanted to, for example, stay below 1.5 degree Celsius increase over pre-industrial levels at the with the probability of 50% or with the probability of 66%. I quickly looked through your paper. I didn't see that chart in your paper or in your slides. You also indicated that you had done the calculations at other probability levels. I think it would be useful, for example, you know, the carbon budget with the probability of staying below 1.5% at 66% means that there's 1/3 chance that we will blow that carbon budget, I'm sorry, that we will blow that temperature constraint at that carbon budget. So could you make that slide available? And in addition, can you make a slide available that shows, for example, the budget at, for example, a 90% percentile range?
Yeah, I'll start with the question on the energy and the different carriers. A good question, and yeah, that would be interesting to know the answer to that. Just yeah, fossil fuels flattening. I'd be a little bit more cautious in the wording of that. Coal, certainly, we see something going on interesting. Oil is growing pretty steadily and not much ups and downs. And gas may actually be accelerating, so I'm still a little bit nervous there. But certainly on the wind, solar side, things are growing rapidly, and also I'll put in electric vehicles. Yeah, there's a couple of questions there. Where is that those renewables growing? And if they're growing in a developed country, a rich country, where energy consumption's generally leveled off and flat, then we get substitution. So the solar, wind might displace coal. That's what we see in the US and in the EU. If you go to a developing country, China, India, where the economy is growing rapidly, the solar and wind at the moment can't grow fast enough to overcome or to explain for all demand. So fossil fuels are also growing in those countries, which is a problem. At some stage, you know, the exponential growth will go into a linear growth and so on, and there'll be various constraints on that. When that happens, you know, we don't know how much policy support is required to keep the renewables growing at exponential rates. Is an interesting question, whether costs alone can do it or whether policy needs to push in renewables, whether we need policies, and I'd say we do need policies to take the fossil fuels out. So it's not just enough to support the clean technology, but we also need policies to take out the dirty technology. If we have that in place, then that might even push along the renewables further. So I'd love to know the answer. So, and I think about that exact question myself. Just to add an anecdote on EVs. So Norway is often talked about for its rapid penetration of EVs. So electric vehicles are about 40% of new car sales in Norway, which is impressive. Like that's basically every second car. But still, you don't really see much effect happening on transport emissions. It takes time for the infrastructure to change over. You've got to displace cars, not just add to the stock, and so on and so forth. And I think we need complementary policies that support those new technologies, but also take away the old technologies. And I think that's one of the missing pieces. We're not having those policies taking away the old technologies. I could touch on the probabilities, but I'll leave that to Joeri.
Yeah, you're right. In the paper, we don't have that chart, but in this report, on constraint-eu.org, there we have it. And also in the IPCC special report on global warming of 1.5, we actually, instead of showing for 1.5 and 2, we show it for 0.3 degrees of warming from today, 0.4, 0.5, 0.6, so for every little increment. Going to the tails of the distribution is technically no problem, but in terms of confidence, it is a problem. If you just produce a number and you don't have lots of confidence that the distribution that you assume makes any sense or is the right distribution, then that number is not very informative. And then finally on the different probabilities, the 50%, the 66%, I think it's maybe good to be aware that we will not achieve probabilities. We will either achieve it or we won't. And so these probabilities really, what they really tell you is that if today you develop a strategy that has a 50% probability of meeting the target or not, then you in one out of two cases you have to be prepared to take more stringent action if it took in the next, be it NDC round or national policy cycle, if you end up to be at the wrong end of that 50%, and the same with 66%. So I think it's more about designing robust strategies that can be adjusted over time to still make it to that one number or that one general objective that you want to achieve.
Do we have more questions? I think I've been ignoring this side of the room. Anybody over there? Oh, active side. Okay, there you go.
Thank you. It's been an extraordinary workshop. Thank you so much.
Lovely. And one question over there.
Hi. Yeah, my question was related. So the remaining carbon budget is really quite small. So if we're going to hit 1.5, those cuts are pretty hefty. And I noticed no one here so far has talked about negative emissions. So that was where I was going, was a question about negative emissions. And how much can we translate 1 unit from the carbon budget now into a negative emission in the future? How transferable is that?
And I think Richard had one more question at the front.
Thanks. So, well, before my question, if I could just plug our side event on tipping points on Friday at 2:30 in the UK Pavilion, if you want to hear more about tipping points. But my question, it picks up on the probabilities question. It's for Joeri, I guess. Does it make sense maybe to think about flipping it around rather than looking at flipping around the approach, instead of looking at probabilities of reaching a warming level, frame it in terms of levels of climate sensitivity? So if you assume a climate sensitivity at the low end, that's your one carbon budget. If you've got climate sensitivity at the high end, you've got an even lower carbon budget. Does it make sense to look at it in those ways rather than the probabilities, just as an alternative?
Okay, let me answer those two questions. First, on the reversibility, basically, can we put one ton too much now and just pull it out later? This all goes back to the risk perspective. That means that you basically are committing the world to enter into a state that you currently consider to be unsafe, with impacts that you consider to be not tolerable. And during that period, you are now signing up to achieve global carbon dioxide removal from the atmosphere net. From the physics point of view, the feedbacks that I spoke about are expected to be what we call enhanced or be stronger, so they might really counteract the effects or your efforts to reduce warming again. It doesn't really mean that it will become impossible as far as the current evidence shows, but it definitely doesn't become easier either. On the probability of and whether to frame it in terms of climate sensitivity, you can do that, although we actually also have a really nice plot about climate sensitivity over time, or the different estimates. We don't see much progress in narrowing that range, and I don't think that 5 to 10 years from now we will really have narrowed that range. So we will just be providing 3 numbers and people will pick their climate sensitivity. So another way of that one could frame this, instead of saying for this temperature level you have this carbon budget, is saying this carbon budget gives you this distribution of temperatures. So if you emit 500 billion tons, then you have I don't know, I'm just going to make up numbers now. So you have like a 50% chance that you limit warming to 1.5. You have a 90% chance that you limit it to 2. And then but you still have a 3% chance or 5% chance that you still end up with 2.5. And that's another way of framing it, but it's challenging because you need to kind of fold all the uncertainties in a different way. And yeah, it's a big origami, and we haven't solved it.
Just a slight, maybe you would say alternative, or building on that discussion point, I suppose. So a little bit twisting your question is when we talk about the climate sensitivity, we say, you know, it's got some median, maybe it's around 3 degrees, but the range is 2 to 4.5, and we very much discuss about it that way. Whereas when we talk about carbon budgets, we talk about this in particular 66%, which is taking one part of the distribution. So again, I can't pluck the numbers out of my head, but it's an analogy. It's like we say the climate sensitivity is 4.5 and base our analysis on that. An alternative approach would be to say the carbon budget for, let's say, 1.5 degrees is a range, just like we would say the range of the ECS climate sensitivity is 2 to 4.5 degrees. We could say the range of the carbon budget is the distribution, in a sense, or some measure of the distribution. So at the moment, we just give one part of that distribution, which is indicating, making assumptions about what the distribution is like. But a consequence of that is the budget is very small. And if we go to 90%, we'll make the budget even smaller. So, what are we trying to do? Just make the problem impossible? So we can always look at the extreme case and say that we should have stopped emissions, 10 years ago to 0, which is maybe the case for a 90% or a 99% probability or whatever. So, I think we could have a more equilibrium climate sensitivity way of framing the carbon budget, a range of numbers instead of a number. And that might give a bit more agency, a bit more hope that we can solve the problem. So it's a slight variant, I guess, of what you were suggesting, yeah.
I think we have time for a couple more questions. Does anybody have any questions or comments still? There's one up the front there, yes, thank you. In the Finnish corner.
Indeed, Oras Tynkkynen from the Finnish Innovation Fund, CICERO. Today we heard that the emissions of CO2 are projected to increase by 0.6% this year, and last week we heard that in order to limit global warming to 1.5, we would need to reduce global emissions, not only CO2 but all greenhouse gas emissions by 7.6% annually. I wonder if you could reflect on these numbers and perhaps provide some of your views on how to get from 0.6% increase to 7.6% decrease, if you can see a pathway of doing that at all?
I was just saying, maybe that's a good question to wrap up on, and we can each give a, because we're getting close on the time, so maybe we can each give our thoughts on that question, starting maybe from Paola. And yeah, good question.
Yeah, so maybe I'll be quickly. Finland is good because you have a net zero that is much earlier than 2050, but a lot of countries don't have a net zero date or have a net zero date that is 2050, but that's pretty much it. They have not come up with a trajectory that is credible or like adjusted to that 2050 net zero. So I think this will be a really good start if each country from their national circumstances were to think on a credible pathway on how to reduce emissions to net zero as soon as possible. And in many countries like Finland, that will be much earlier than 2050. And then look at what sectors are the ones that will need the hardest action. And that's where you need to start planning really quickly and adjust your policies. For instance, again, I go back to the power sector, your energy planning. Adjust your energy planning to fit into that very steep trajectory.
Yeah, very much along that vein, and also echoing what Paula said in the very beginning. It's really about setting a trajectory and trying to follow and pursue that trajectory, knowing that any trajectory or any strategy that one thinks about, there will be things that go very well and things that go very badly. And so the 7.6% decline on an annual basis is can be like a benchmark, but it could well be that we start very slowly but try very hard, and that it then accelerates well beyond that percentage. But that will only happen if we try very hard in the beginning. And at this point, I have not seen any country trying really hard.
Yeah, kind of following up on that really, I think it's more of a political question than a scientific or a technological question. I think that the options are already there in terms of how would we otherwise generate our energy or fuel our lifestyles. So it's really a question of political willpower and leadership, I would say.
Yeah, so I tend to think 7.6. Where emissions are increasing, they've been increasing for decades, and to say suddenly flip to a 7.6 reduction is going to be, let's say, a challenge, to put it mildly. But we have to remember that every reduction that we make avoids some impacts in the future. And maybe when we start reducing emissions, like Joeri was saying, maybe those reductions are not as hard as we thought. Maybe we can get going a little bit better than we thought. But I think when we start to frame the problem as going from one extreme, let's have emissions going up all the way to the other extreme, which is emissions going down at the ideal level, 7.6% or whatever, is maybe a step too far. So we need to, cut it down into little pieces. First of all, we have to get emissions to peak. And then we need to get emissions to go down. Then we need to get them to go down even faster towards net zero. And we're stepping off into the unknown. We don't know what that pathway is going to be like. We've never deliberately reduced emissions. Emissions have gone down accidentally with emergence of nuclear power, for example. That wasn't a strategy to reduce emissions through financial crises, although that's not the ideal way necessarily to reduce emissions. But maybe if we start to reduce emissions deliberately, maybe it's easier than we think. Maybe those reductions happen faster. Maybe solar and wind aren't as scary as possible. Maybe electric vehicles are actually nicer than our petrol guzzling cars. Maybe electric bikes make it easier to get. So there's a lot of potential benefits out there, and maybe we'll like the pathway we're on when emissions go down. But if we go down at 5% per year and we end up at, 1.7 degrees or wherever that would take us, then that's better than being at 3 degrees or 3.5 degrees and so on. So we have to take whatever we can get. Each reduction is better than no reduction. Each reduction now avoids the need for negative emissions, so getting to the risks that you were talking about in the future. So I think Joeri put it very nicely that I haven't seen any country putting in the effort, trying hard enough yet. So nice way to end.
Thank you very much, and thank you for your great questions. And please give a round of applause to Glen Peters, Matthew Jones, Joeri Rogelj, and Paula Jangwas-Para. Thank you.